Okay, welcome back everyone to day 2 of the CyberBot Educator Workshop, Spring 2022 edition. Here is a repeat on the link to the slideshow, which I'll go ahead and paste into the chat. So today we will start with questions and answers. Following that, we'll look at the Python scripts that students will be using to make their CyberBot do various navigation and maneuvers, and also talk about the scripting techniques and or computer science concepts involved in succeeding with that. After that, we'll build and test the touch navigation, which we call whiskers, because they're like little whiskers in front of the robot. You'll see when we get there. After that, I'll talk about light and infrared navigation, because those are the other 2 sensors that come in your stock kit. And for the assignment, we'll build and test an infrared sensor circuit. So those are like whiskers, but you don't actually have to bump into the object to detect it. And we'll also have you log into learn.parallax.com. If you've never done it before, you will have received an email inviting you to do it. And if you've done it before, you won't have received an email. And or rather, you'll have received an email, but probably much earlier when you signed up during some other occasion. We'll also make sure that we understand the CyberBot module and the hardware interaction it supports. And let's see, I think those are the main bullet points. So moving on to the questions and answers. Let's throw the mic open. Go ahead and unmute yourself and ask any questions that may have come up between either been on your mind since Monday or possibly have come up between Monday and today as you were building your robot.
Oh, we do have a mention from Christina. I am missing 2 screws, the 7/8 inch pan heads. We're sorry about that. Those are packaged at the hardware suppliers and they should not be missing.
I had another email from somebody who was missing it, but he said he found them.
Oh, okay.
I looked through everything. I have a lot of extra screws, but they're small ones.
Okay.
Okay, I think the gentleman who used the 7/8 said that he ended up using those to attach the battery pack by accident instead of the nylon screws. So did you use nylon screws in your battery pack?
Let me double check. I want to say yes, but let me double check.
Yeah, or anywhere else, because if those long 7/8 inch screws went into some of the standoffs or holding on the servos, that would also explain why you don't have them.
Okay, I'm going to look it over real quick.
Okay, great.
And I'll just take this opportunity to point out that when you've got a bunch of kids building and taking apart and rebuilding the robots, that little pieces can go missing. We do sell the hardware baggie of parts as a separate replenishment item, and I will put it in the chat.
Okay, yeah.
And if anything is ever missing when you get your new kits, you can contact education@parallax.com or sales@parallax.com, and we'll send out replacements right away. Okay, end of commercial.
Okay, so actually, I'd like to speak to that commercial a little bit more. These are 2 kits that I think I had a question about other things to purchase from somebody over email, and I didn't really think about this. I'm sorry about that. These 2 kits right here are really nice to have, several of them for your classroom, and I'm pasting the links into the chat. And I do think that I have this scheduled for Friday, but I'm pasting them in now. So this is the electrical and electronic parts that come with the kit, and students will drop and accidentally kick, smash, or accidentally, any number of things can cause these to disappear from a kit. And so having a few extra bags of these parts on hand, both the electrical and electronic, and the washers, screws, nuts, etc. All of these things, if you've got several bags of these along with your robot kits, it'll help out when a student loses or can't find or damages a part. Thanks for mentioning that, Stephanie. Okay, so that was a spare parts question. Okay, well, I have a question for you. Okay, so we all had a cyberbot module, or we all had hex files with cyberbot modules, and they should be very recent in your downloads. And so, for example, here in my downloads, I've got center servos.hex, and I've got script with cyberbot module.hex. And both of those are going to have the cyberbot module in them. And you can just open your file explorer. That's going to be files in Chrome, File Explorer, or Windows Explorer in Windows, and then Finder in Mac, and look in your downloads, which is going to be along the left. And especially if you sort it by date modified, so that they come to the top, you can usually click it once or twice to get it so that your most recent downloads come to the top. Then you'll see your hex files that we did yesterday. And so here is one we created, and then center servos was another one that has the cyberbot module built in. And there it is. So make sure that you've got a hex file open in your python.microbit.org editor that has that cyberbot module, because we're going to start doing some scripts to make the robot move. So we'll definitely need that. Before I move on, let's just kind of get a read on the folks who are not video muted. Have you, those of you who are able to nod, can you nod or give me a thumbs up or something? And then click the thumbs up if you, okay, excellent. So you've all got python.microbit.org open, and you've all got a script open that has that cyberbot module added to the project. Okay, fantastic. Excellent work, everyone. All right, so with that then, let's move on to navigation with just a reminder that if a question comes up, you can feel free to unmute yourself, or if you're more comfortable putting it into the chat, either way is fine. All right, let's talk about navigation. First of all, a little bit of orienteering with the cyberbot. Take a look at your cyberbot, first of all, and make sure that the white breadboard, that little white plastic piece with the many holes in it, is mounted roughly above the drive wheels. So that the thing we want to avoid is having that breadboard over by this ball, which we call the tail wheel, although it's really a tail ball. This is a tail dragging robot. And so forward is going to be away from that tail ball, like so. Basically, forward will be to the right on the screen as we see it. then backward will be toward the tail ball. And then if you imagine you're sitting on the breadboard facing forward, holding the steering wheel, then you've got an idea of what a left turn and a right turn would be. Now, scripts to make, one of the things we noticed is that the servo turned slightly. Now, I don't want you to run these scripts because it will cause your robot to freak out, because these are full speed examples here. And so if you run one of these, I'll give you a script in just a minute. These are how to make an individual servo, this time connected to the P18 socket, go full speed. So full speed and some is 200. And that would be full speed counterclockwise. And under the hood, what this 200 actually does is it causes the cyberbot board to send these brief 3.3 volt pulses. And a 3.3 volt pulse is what makes the light on the microbit also turn on. When you rapidly, or when you send 3.3 volts to a light on the microbit, it turns on. And then when you send ground to it, it turns off. And so if you could actually, in theory, connect a light circuit to that white signal line, and you could see the light flicker very rapidly, because 20 milliseconds or 20 thousandths of a second means that this is repeating 50 times a second. So it's actually too fast for the eye to see. But what you would see is it glowing dimly, a light glowing dimly, because it's turned on briefly every 50th of a second, and your eye will see that. And the longer you turn it on, the brighter it would be. So this is turned on much less time, and so it's dimmer. Let's go to the bottom, though. At the bottom is the signal that you sent to center your servos. So this is the stay still signal, and we actually had to adjust the servos to stay still. That stay still signal lasted for 1.5 milliseconds of on time for every 20 milliseconds. Full speed clockwise is negative 200, and the end result is a 1.3 millisecond high signal. That's actually 200 millionths of a second less than 1.5 milliseconds. That's where the 1.3 comes from. Likewise, positive 200 is 200 millionths of a second more than 1.5 thousandths of a second, or 1.5 millisecond. Another way to think about this is if you multiplied all these times by 100, then you'd have 2 seconds instead of 20 thousandths of a second, and you'd have 150 milliseconds of high time. And if you connected a light to that, you could actually see a slow motion version of the brief blips that are transmitted that tell the servo what direction and speed to go. Now, speaking of speed, get back to that slide in a second. Here's a graph of the speed. So when you're using 0, and that's the 0 argument in the speed method call, bot.servo speed of 0, when you're using 0, you're sending that 1.5 millisecond or 1500 millionth of a second or microsecond pulse. It stays still. See, we have 0 RPM over here on the left axis, the vertical axis. And as you get towards 100, the speed will increase, either clockwise, and we give that a negative here, or counterclockwise, and we're giving that a positive value.
Can I pop in with some questions from chat?
Yes, please.
This is one about forward and reverse control and voltage. We have a question: does a negative 3.3 volts reverse the servo, or is a negative voltage interpreted as 0? So I guess we're looking at voltage control versus signal control. Yeah,
that's a good question. Okay, coming back to here, negative voltage is something we don't want to do to this servo. the servo does that internally for you. It actually changes the direction the current goes through the motor, although it always keeps the voltage positive. So these are all positive pulses, and what actually causes the direction and speed is the amount of time the pulse stays high. So the neutral or zero speed is 1.5 milliseconds pulses. Full speed counterclockwise is 1.3 milliseconds. Full speed clockwise is 1.3 milliseconds. Full speed counterclockwise is 1.7 milliseconds. So it's simply the amount of time the signal stays on or high or 3.3 volts that tells the servo what direction and speed to go. And if we take a closer look at the relationship between voltage and time, what you'll see is that if you give it 200 as full speed, so that 200 was, full speed and some counterclockwise, negative 200 was full speed and some clockwise. But if you say 100, well, it's still pretty much full speed. It's very close, not quite. The speed's starting to drop a little bit. When you say 50, you're going to get pretty close to half speed. When you say 25, which would be about here, you're going to get pretty close to a quarter speed. If you say negative 25, which would be about here, you're going to get pretty close to negative quarter of full speed in the opposite direction. So positive is going to be slow, faster, top speed. So positive values in our speed argument, and negative values are going to be faster in the clockwise direction. Up to about 100 is full speed. That's when you can start changing values and seeing an actual change in speed. So 200 and negative 200 are full blast. Now, what's happening is the microbit is actually sending it that information to a microcontroller that's underneath this white breadboard. If you look up and under the robot, you'll see this small square chip. And this microcontroller, these two microcontrollers are having an ongoing conversation. And whenever you use that statement to make the wheel turn, this microcontroller, the parallax propeller microcontroller, will use that information to send signals to the servos. It can also use information to send and measure signals that are on the I/O sockets to the left of the breadboard. We'll see more about that in a little while. Okay, so I had a question between Monday and today about why did the robot turn in place when I said 50-50? Or let's just say 75-75, because I have a script somewhere that says that. Okay, so here is, if this were instead positive 75. So making both the wheels turn about 3/4 speed counterclockwise resulted in the robot turning in place. Why is that? The answer is because if you look at the right side of the robot, to make it go forward, which is now to the right of the screen, the wheel has to turn clockwise. Look at the left side of your robot. We'd be making it travel towards the left side of the screen while looking at the left side. And now this wheel, in order to make the robot travel that direction, has to turn counterclockwise. The servos are facing away from each other, so they have to be turning opposite directions as you're looking at them. And there's a device there's a mechanical piece in a car, or well, in old cars that have internal combustion engines, called a differential, that also does the wheels in opposite directions so that the car will move forward. Okay, so let's go ahead and try this out. I'm going to paste this script into the chat and we'll have everybody try out. It's going to go forward for 3 seconds. So get ready to hang on to it. Or another thing. Okay. So these two statements set the servo speed, how long the robot travels at that speed, which translates to how far the robot's going to go, is set by this sleep statement. Following the sleep statement, we're turning off the signals to the servos, which will make them stop moving in the same way that the 1500 signal will make them stop moving. If it falls out of calibration, the advantage of using none to just simply stop sending servos or sending signals is that the servos will stop even if they're a little bit out of calibration, whereas using a value of 0, if it's a little bit out of calibration, the servo might turn gradually as it's sitting there. Okay, so let's paste this in. And here's the chat. There you go. So remember, you want to have a script opened that has the cyberbot module added to the project. And then we can go ahead and paste this example script in. And again, normally we'd want to have the students type it in, but for 4.5 hours I think there's probably a good 60 hours of class material for the cyberbot available. So it's hard to cover all that in 4.5 hours. So I'm trying to hit the main points. So, so while you guys are getting your cyberbot ready, I'm going to plug mine in. I forgot to do that before the start of the session. Plug in the battery pack and set the 3-position switch to 1, but only while loading the script. So this 3-position switch here So while we're loading the script, we want to have this 3-position switch set to 1. And then we can go ahead and load the script. Again, that's click connect and then click flash, and then the script will be loaded. Now, because of the fact that the 3-position switch is in 1, nothing is going to happen. So the next thing to do is to reach underneath the USB cable, or to set the switch to 2. Now, when I set the switch to 2, now the servos have power, but nothing is happening. And that is by design. What we want to do is restart the program by pressing and releasing this reset button right here that's by the USB cable. And when you do that, I'm going to have to grab my robot because it's going to lurch forward. Nothing at all happened. Okay. Press and release reset. I don't know why nothing happened the first time. I'm a little worried about that. Let me know, folks, if you're able to press and release reset and have your robot go forward for 3 seconds. One thumbs up. Thank you, Mark. Can I get some more thumbs up?
We have a question on batteries.
Okay, excellent.
Your batteries in there okay, Andy?
Oh, well, that's a good question. They haven't fallen out yet, so.
We have lots of thumbs ups, so I think we're doing okay.
Okay, fantastic. So let's
Oh, here is an assembly question. So I'm assuming that if mine goes with the balls first, my servos are reversed?
Oh, that's an excellent question. Thanks for asking. Actually, yeah. So basically what you'll want to do is unplug your servos and swap them. So what I'm doing is I'm swapping them so that now I'll have the we didn't want it result of pressing and releasing the reset button
But
and
it might
having the
be-
servo go backwards.
Might have been a good idea to put your switch in position 1 when you do that to take away power from the
Oh,
headers.
shame on me because I'm adjusting
You're
electrical
watching.
circuits. Yeah, so I set the 3-position switch to 0, disconnected the cables, swapped them, reconnected.
Yeah,
And
we
now
have-
when yes, go ahead.
we have questions coming in quickly. Is there an issue if I flash with a switch in position 3? The robot simply moves forward.
That's correct. There's no issue with that. It's mainly a safety thing. In general, the students have to end up getting in the habit of leaving the switch in position 1 so that the robot doesn't move. They load their script, then they unplug, and you have to hold on to the microbit when you unplug it. They'll unplug the USB cable. They'll take it somewhere, and you can either turn it off and then turn it on, and it'll do its thing. Or you can press and release the reset button and it'll do its thing. While it's connected to USB, the only way to do it is to press and release the reset button.
We do have a couple of people who are having difficulties. There's 3 people at this point who would, or 2 people who would like some help.
Okay. Now, does this have anything to do with the cyberbot module? Of the 3 people, are any of them missing the cyberbot module in their script?
No one has mentioned that.
Okay.
Maybe you can stop and take a look at the messages that are coming in quickly.
Yeah, working on it.
Okay.
Okay.
I will post in something about the 3-position switch while you're reading the other questions because it's well explained in the tutorial. So I'll put a link for that page.
The robot lurches to the left, assuming the servos are powering up. Do I need to adjust the center position again? Hopefully not. Let's see here. All right. So for the person whose robot lurches to the left, what we want to do to check and see if you need to adjust the center position is to go back to 0, 0 on your speeds. Let me zoom in on this a little bit. Okay, so try setting your speeds to 0, 0. And then with that, click connect, select your microbit, select connect, then flash. And if you leave it in position 2, the program should start running as soon as you flash, and the correct result would be that the robot stays still. If your robot stays still, it means that your servos are still centered. If your robot starts moving around, that means one or both of the servos are out of center.
It's whenever I go from position 2 to position 3, it like powers and then does a little lurch and then it stops.
Okay.
And given your instructions, it does not move when I do the 0, 0. So I just thought it was odd. It's like there's a surge going through when I go from 2 to 3.
Yeah.
And then it pauses as it should as the program loads. So I just thought it was odd.
Yeah. The servo motors will do a little, that it's exactly right. There is a current surge into the windings of the servos when they get power. into the windings of the DC motors inside the servos when they get power. And so they will do a little turn. And so if your students find that to be frustrating, one thing to do is to suggest to them that they hold the robot up as they turn power on and then set it down. And then ideally, what you can do in your scripts is add something like a little delay so to give them some time to set the robot down before it does its maneuver.
Thank you. That's a good idea.
Yeah. There's another thing I'm going to talk about, which is we're going to add a speaker pretty soon. And once that speaker is added, that speaker will signal the start of the script, and it'll take some time to do so. That will also give them the time to set their robot down. Okay, Stephanie, do we have any more?
We do. Could you show, pick the robot up and put it, or turn it over near the camera so we can see where you're pushing the reset button?
Okay, the reset button
Great.
is right by the USB. This is the USB connector. This is the reset button. So right now, all I have is the center script, but you're pressing and releasing that reset button right there. How's that for a demo? Is that clear enough where I'm pressing?
Yep, that is
Okay.
good and clear. We have two folks who are just simply cannot get, where one, Paul cannot get his to load code, and Laura says mine isn't working, but I don't know what the issue is for her specifically.
Okay, so on the cannot get to load code, has it loaded code before?
See, Paul, can you unmute yourself maybe?
Actually, I'm all set now. Alberto helped me out. He got me. I was looking for the link for the plugin that you have to add.
Oh,
Okay, okay.
MicroPython. So I'm all set now. Thank you.
good.
Yeah,
Great.
now, does anybody else not have, I can, I think I'll paste in a copy of my script that has the, see, where did I put that? Hopefully. Nope. There it is. Okay, so I put a copy of an empty script, or rather the center servo script, in my Google Drive. So I'll go ahead and paste that in. You can download that and then drag and drop it into your python.microbit.org editor if you don't have, and I'll go ahead and follow the link. So here's the link. When you follow that link I pasted in, you'll see the option to download. And when you click download, a download will appear. And so this is my third copy of center servos. And then, so here is center servos 3. And hit load save, and you'll have the files there. So it's best to keep files, hex files around that have that cyberbot module added. Now, if you're doing microbit only things, don't use a script with the cyberbot module. Just use a script that does, if you're going to leave the robot off and have the microbit disconnected, make sure to not have a script that has cyberbot.py in it. Because cyberbot.py waits for an active connection between the here we go. Cyberbot.py waits to detect active communication between the microcontroller, between itself, between the microbit and the microcontroller, the propeller microcontroller that's on the cyberbot board. So if you have the microbit unplugged from the cyberbot and you're doing something like a step counter or some kind of radio communication that doesn't require the cyberbot, then either remove that module from the script or from the project before you start. And to do that, don't do this because we need it right now. But there's a little trash can by cyberbot.py, and that's one way to remove it. But I think typically an easier way to remove it would just be to reload the page. And when you reload the page, you can go look at load save, and then you won't have the cyberbot module in there anymore. And you can just add in your Python script from there.
Can we check in with Laura before we move on?
How you doing, Laura?
Yeah, I don't know. I mean, I was late, so I'm sure I missed something, but I did the code and everything, but it's not moving. So I'm sure I just missed something.
Well, okay. So step one, do you have the cyberbot module? Were you able to check to make sure that you have the cyberbot.py module in your
No, and I don't know. My computer's acting up, I think, because when I try to download something in there, it says that it can't.
Okay.
So I don't know.
Do you want me to try a breakout room, or do you want to hang on until the end and we
I'll
can
just
do
hang
one-on-one
on
after
because
the
I mean,
end?
yeah, let's just go ahead and move on. I'll keep working on it and just see what happens. So.
Because we'll have time after the completion of the presentation to turn off the recording and help people one-on-one.
All right, thanks.
Okay, then. All right, so let's talk more about maneuvers. If 75 and -75 to the left servo connected to P18 and the right servo connected to P19 result in forward, what would you guess results in reverse? Well, if you guessed swapping the signs of those speed arguments, you guessed correctly. Some other things you can do. Oh, and I want to emphasize that these are all excerpts from existing tutorials. So for example, and I put the links of where this information is coming from near the bottom of each slide. And so here is that information in the actual tutorial that the students will be trying out. I need to get that back anyway. There we go. So pivoting would be keeping one wheel still and making the other turn forward, I should add. Or at least if you want to pivot in a forward direction, you can keep your right wheel still, make the left one turn with +75, and it'll go like that. If you make the left wheel stay still, remember that opposite directions are for forward, so you need a -75 on this wheel to make it turn forward and have the robot pivot forward on its left wheel. The robots can also turn in place, and that's basically what happens if you have the same value. So with positive values, it'll turn in place to the right. With negative values, it'll turn in place to the left. And so let's see. I'd like to go ahead and try some of those. So here's a quick little trick. You can simply shade, right-click, copy, and then right-click and paste. And then you can change a value. So to make it go forward and backward, we could do that.
Can I jump into the question?
Yes, please.
From Mark, can we use both Python modules with robot on? For example, play music while robot is moving.
Yes, yes, you definitely can. And we'll take a look at that. Let's see. Because these servo statements are basically set it and forget it. And so you can set a speed, and then instead of sleeping for 3 seconds here, you can play, if you wanted it to still go for 3 seconds, you'd want to play 3 seconds worth of song. And we'll get to how to play music in just a little bit. Next up, we come to some computer science lessons. This one on for loops. Here's an example of a script that I'd like you to try where it goes forward. I'm going to make this a smaller value too. We're only going to go forward for 2 seconds and then hopefully make a 90-degree right turn. We'll probably all need to tune this a little bit. So here we go to paste it into the chat. Flash. Okay, I'm going to run that again. Remember, that's pressing and releasing the reset if you're in position 2. So here we go, forward for 2 seconds. And then my cable prevented it from doing a full, its full turn. Oh, that's a pretty good quarter turn. Maybe just a little bit further. Okay, have we all got the forward and turn 90 degrees-ish? Okay, I'm not seeing enough thumbs up, so we'll wait for a couple minutes. Oh, good. More thumbs up. Now, if it doesn't turn quite far enough, like mine didn't really turn far enough, I'm going to, instead of 1150, I'm going to make mine 1200. And also, because of the fact that my work surface is kind of small, I'm only going to go forward for 1500.
We're getting yeses and thumbs up.
Oh, excellent. Okay, so I'm happy with my forward and 90-degree turn. I think actually, though, for me, I'll need to cut it actually to 1000 in order to have it navigate on the desk properly. Okay, so now what you can do to emphasize the counting lessons that we did in the homework is say, all right, take that maneuver and indent it, and then add 4y in range 0,4 to get 4 repetitions. And then what you've done is the student has taken some code that does something that's not all that interesting, just forward and turn right. And by repeating it 4 times, we have something more useful, which is basically drawing a box. There's that script. And so all we do is indent the forward and face right, and then add for something. I think they used X. And add a colon and flash that. And for this, you may want to unplug and put it on the floor. I don't know if I got mine to go tightly enough to go on the desk. We'll see here. Oh, not quite. So close. Let's see if I can get it a little bit closer to this edge. I still need to increase my turn value a little bit.
Are you pressing the reset button to make it run without the cable?
Yeah, once you're disconnected from the cable, there are two ways to do it. One is to simply turn the power off and back on. And the other is, all right, so let's say you turn the power off and back on, and it's gone through all its maneuvers, and you want to do it again to take a closer look and try to examine some kind of misbehavior. Okay, so now the program is stopped. You could just turn it off and back on, or you can go under the microbit board to that reset button that's by the USB connector, and that will also restart the program. So that's when you're disconnected. Either way will work. When you're connected to USB, only the reset button will restart the code. The script, I should say.
Can we see your code again for a second? Can you make that visible? There. It looks like your indentations don't come through when you copy and paste into the chat window.
Oh boy. So I pasted that from the slide. So let's try it straight from the
from the slide. Okay, let's see.
Okay, so I'm going to paste it in one more time. Let's see if these indentations come through.
Yeah, when you paste yes.
Oh my.
That's a big difference.
That's a huge difference. Sorry, everyone. Okay, object lesson on the importance of indentation. We really don't want to worry too much about tuning it to a perfect square. If you were able to see the repeat of 4 forwards and turn rights, that's good. And then tuning can take place after the session is over. But I want to make sure that everybody got to run the code with it correctly indented. Okay, everybody got it? Are we good? Thumbs up. Okay, good. Head nods. All right. Just shout out if you need a little more time. There's also ways to make bits of reusable code in your script. They're called functions. We didn't do functions in the homework. It's best to introduce functions kind of on an as-you-go approach. And when students realize that their program is getting really long, then that's the time to start organizing it and adding in functions. So we have 3 functions here. And by creating these functions, what you can do is use 2 statements, and you can repeat those where needed. So the straight function call would be would cause the script to jump up here and do these statements, and then jump back down, and then find the next thing to do with it, which is the right function call. So it'll jump to here, and then it'll execute the statements for the turn right maneuver.
Do the functions have to be placed at the top?
They do have to be placed above where they're first called. And I honestly don't know of a way to put them below. Like in C language, for example, you can warn the compiler that they'll see a function call and just to hold off, because eventually the compiler will get to it. And then that way you can put the function below the main code. As far as I know, in Python, you're placing the function definitions above your main code. And any Python experts can jump in and correct me if I'm wrong on that.
Thank you.
Certainly. Functions can also receive arguments. Stephanie, which one's the parameter and which one's the argument? I completely forgot. The argument's here, right?
You need to pass an argument to a parameter.
Okay, so the parameter is,
It's the
in
thing
this
that
case,
needs the value.
duration. Yeah. So,
Yeah.
so you can modify that straight ahead function so that it has a built-in variable named duration. And then when you call the function, you can put the duration as an argument to your function call. It'll get passed to the function's parameter and then used to control, in this case, how long the robot moves forward. And you can get really fancy with your functions. I'll leave this one for you all to, or I'll leave most of these for you to try between sessions if you want to explore this as a way to help firm up some computer science concepts. So now we have a function with multiple parameters. That function has to be called with multiple arguments. And in this case, maneuver 100 full speed forward, 100 full speed forward, and then 2000. Now, look at this. Another cool thing that the function does is it negates the value of that right servo. So, so you can make this maneuver call, and then you don't have to worry about remembering to do a negative speed for the right wheel and a positive speed for the left wheel to go forward. You can just have it be intuitive and say 100, 100. Well, that's forward. And then, VL gets 100, VR gets 100, and then the left servo gets that speed and the right servo gets the negative of the VR speed. And then that way it just automatically works in a much more intuitive way. So here's an example of a really good function that I would use in a navigation contest. And let's see, there's also an acceleration example in here, but with the hour and a half, we really need to move on. Okay, so everybody, I'd like you to just jump into your parts bag, your electrical parts bag, which will look like this. And grab the speaker. Yes, there should be a speaker. Yeah, there is a speaker in there. So it's in with your red LED lights. And what I would like to do is leave it up to you between well, I'll show you how to play music. And because of the fact that the servo speed commands are set it and forget it, we'll go ahead and leave it to you guys to add a little bit of music into your navigation. That's a fun little extra thing. So find the little black cylinder that is the piezo speaker. See if I can give you a close-up of this. Okay, how's that look? So that's what you're looking for. And go ahead and insert it. There's going to be a little plus sign on the top of the piezo speaker. And you want that to line up with the plus sign on the two sockets here next to the servo ports to plug in the speaker. And here are the first few notes in Happy Birthday, which I'll paste into the chat. So I'll save this as navigate, or let's see here, box, navigate.
I see a couple of people mentioning in the chat is it the piezo speaker that's loose in its socket? There should be a part on the back that when you put the piezo speaker through the top.
Yeah, the pins should sink into this little these little sockets right here.
Is anyone's board missing that socket by chance? Who's telling me that we have like Monica? Is there a little socket on the back of the board on the other side from the piezo speaker?
Right there.
I agree with Mark. I mean, you put it in there, but it's still loose. Sorry for like unmuting without requesting.
No,
Oh,
no,
that's quite all right.
yeah. Yeah, we appreciate that.
Hmm.
Well, yeah, I mean, I'm noticing that mine isn't really, I mean, they're not, it's not difficult to insert at all, but I don't, and the speaker even wiggles a little bit, but you know what? Those clips are still holding on to the pins. So let's give it a try. Let's see if we can hear something.
Or if you turn your robot upside down, does it fall out?
That's a good test. Thank you, Stephanie. Oh, interesting. Mine did try to, it fell out. That's no good at all.
I wonder if something about our piezo, like the length.
The lead, yeah, or
Yeah.
I think it's more likely that something may have changed in the socket. Let's see if we can get some sound out of it though.
Yeah. or the lead diameter.
Okay, I got an error out of that one. Open serial. Okay, looks like I cleverly hid an area. Oh,
Pound sign.
yeah. Add the hashtag to the pound sign before happybirthday.py. I'll paste the corrected one in. Well, this is rather underwhelming. Did anybody else get sound, or do we need to start looking at
No sound in mine.
okay. Well, we're going to the right IO pin.
We have some with sound and some without sound.
Yeah, I'm definitely one of those without sound. Okay, well, we'll look into that one and report a little bit more on it.
Mine worked on pin 1 and I kept putting it on pin 2. So it worked on pin 1.
Okay, yeah.
The little switch, on the switch 1.
Okay, yeah, because I've got mine on pin 2 or I've got my switch on setting 2, and I'm still getting no audio out of the
And that's
speaker.
what I did, and it worked on 1.
Okay, let's try 1. Yeah, neither 1 or 2 are working for me. I'm going to put it in backwards just for kicks to see if something weird happened with the piezo speaker.
When I flashed my code, I held the piezo at an angle to kind of force the connection between the leads and the socket. And then I was able to get sound out of it. So it's
Okay.
just that they're just not seating properly.
The reason we have a external piezo speaker is because the microbit 1.5 that we developed the robot with does not have the speaker on it, as far as I know.
Yeah, and so that is another thing, is we can use the
We can for this. We wanted our directions to be compatible with either one. It may
All
be
right.
that we were substituted a part, since there's been component sourcing issues as part of the general craziness in the world right now. We
Yeah,
will
this
look into that.
might just be collateral damage from the supply chain crisis.
Yeah.
We'll look at it and find out and let you know what happened. I'll also set up an example for Friday that uses the built-in speaker.
Can you mount the piezo to the underside of the board? Because I see a socket there on the underside.
It's supposed to be going through, it's supposed to be an undermount socket. So where the metal clips in the socket are positioned, that the leads are supposed to go through the PCB and then into the clips in the socket that's on the underneath. So it's supposed to be an
okay.
undermount socket.
However, you can simply build a,
Oh yes, we can also put it on the breadboard.
yeah.
Holding and twisting worked. Yeah, so it seems something is loose about that connection. That, like I said, it could be the lead diameter in the piezo speaker. It could be a change in the slight change in the component sourcing for that undermount clip, likely.
Okay.
Also, those holes are plated on the PCB. Are the holes
Yes.
plated there? Okay. So how about very gently spreading the leads on the piezo speaker so they're slightly wider than the 2 holes. So it's supplying some tension to the side of the holes. I agree that this fussing should not be necessary, but it does help figure things out and to get some sound out of it for today.
That actually didn't work for me.
Oh, okay, good to know. Break out the soldering iron. Yes.
Yeah. Well, so you can also simply build your piezo speaker circuit on the breadboard if you have a microbit 1.5, and then you can change this bot of 22 to bot of, and then the whichever socket you use along the side here. So just a real quick thing about circuits. On the breadboard, if you pick a row of 5 sockets and connect 2 or more wires or leads, part leads into that row of 5, that is how you electrically connect them. And you can even, if you need to connect even more than 5 things together, you can use a jumper wire to electrically connect 2 rows of 5. And then you can connect wires to any of the remaining 8 sockets that are available there.
We did get a report that undermount minding the polarity worked.
Okay.
So actually putting it in the socket underneath. Interesting. I wonder if we were sent the wrong socket and the clips are not where they should be. The narrow part of the clips inside the socket aren't where they should be. It's
Yeah, I mean,
once
the
in a
fact
great
that
while.
the fact that it's dropping out of the board when I hold it upside down, yeah, that's probably,
Yeah, the supplier might have sent us the wrong part.
yep, that's probably an issue with the socket. That's going to be a fun scramble after this ends. Oh, you know what? You guys are the first ones with this Rev C board, so fortunately we don't have a massive recall.
Thank you for helping us troubleshoot.
Yes, we really appreciate it. Okay, so if you connect 2 wires or part leads into different rows of 5, they will not be connected. If you connect rows or part leads opposite the this valley in the middle of the breadboard, they also won't be connected. I heard some good music there. That was great. This is a little overview of the sockets around the breadboard. We have ground or 0 volts, 3 volts, 5 volts, and then these are sockets that if you connect a circuit to it and then you say bot and then 8 in parentheses, you'd be doing something electrically to P8. Or like you could connect the speaker to P4 and then say bot of 4 and then dot tone and the frequency and the duration. And you'd get a tone out of it that way. We also talk about the light emitting diode. It has a longer and a shorter pin. If you connect it one way and apply voltage, it'll let current pass through and give off light. If you connect it in the opposite way, it'll actually just prevent current from flowing through the circuit. We also talk about resistors and their color codes. So this is the list of colors and their numbers. And then there's, for example, red, brown would be, red is 2, so that's 2, 2. And then the third stripe is the number of zeros to add. So we're adding 1 0 for 220. And then there's a percent tolerance. And so all of ours have a last stripe that's gold. And so this measure of resistance, which is the amount that this part resists the flow of current, is measured in ohms with the omega symbol. And this is stuff that's introduced in the cyberbot text. And it also talks about how inside the microcontroller, to make a light blink on and off, it switches from 3.3 volts to turn the light on, internally to ground to turn it off. And in the interest of time, I'm going to skip this light blinking example where we do that. Again, you're welcome to try that at your leisure. We also have a push button example where you essentially press the push button and the microbit script reads the push button and decides whether or not it returned 1 or 0, where 1 is pressed and 0 is not pressed. And the tutorials also talk about how that works out inside the microcontroller. Okay, so next up we have whiskers. I'd like to try to get the whisker circuit built. So here are the parts you're going to need. And again, as always, all of these slides that I've whizzed through have links to their source page. So for example, well, let's see here. I put the wrong link on that one, I think. Or, oh no, what I did was I added a little bit of, basically it calls out the parts because you've already gone through building circuits at this point. It's just calling out the parts by name. So for the presentation, I added the pictures of the parts to get. So you want, these are the resistors, and we're going to gather 2 resistors that have red, red, brown, gold stripes, and 2 resistors that have brown, black, orange stripes. So let me know when you have gathered all those parts. I'm going to gather them off on my table too. And this is the part where either a magnifying glass or a cell phone set to magnify can be very useful. Okay, how are we doing? Oh, I'm seeing heads down, so everybody's still looking for their parts. Okay, I'm starting to see people look up, but not, I still see some heads down, so we're going to wait a little bit longer. Okay, can I get a poll of who's got all their parts? Give me a thumbs up. Okay, or give me a thumbs down if you're still working on it. Got a thumbs down? Okay. All right, so what I'm going to do is jump to the next slide, which is putting on the whiskers. So all you'll have to do is loosen those two front screws with your screwdriver, and then hook the whiskers in. And you want to hook one whisker in below the washer and the other whisker in above the washer. And it's okay if the whiskers are touching each other. You just don't want them to interfere with each other. So for that, turn power off. I'm going to unplug the USB so that I can show you how to connect those whiskers. So we'll loosen up both the screws holding on the front of the robot, and then hook one whisker in above the nylon washer, and then hook the other whisker in below the nylon washer. Okay, and then bring your whiskers forward so that when you're looking at the top, it looks like that. And you want the whiskers to be roughly parallel, these little first length of each whisker to be roughly parallel with the breadboard. And then hold on to it as you tighten. And then that way the whisker will be nicely snugged in that position we want. You may have to kind of push it a little bit. The other tricky part is these 3-pin headers. So the 3-pin headers in the diagram are plugged in here and here. So that's 1, 2, 3, 4, 5, 6, 7 and 10 rows down from the top. So 1, 2, 3, 4, 5, 6, 7, and then 8, 9, 10. Oh, and I didn't even have that showing. Okay, so again, counting 7 rows down from the top with our 3-pin header. So it's going to go 1, 2, 3, 4, 5, 6, 7. Right there. So now this 3-pin header is 7 rows down, and then I plugged in this 3-pin header 10 rows down from the top. And then the next test you want to do is if you push the whisker toward the 3-pin header, you want it to touch the metal part of the pin. And then here's the rest of the circuit. The red, brown resistors are going to go from P7 to that row, and to the lower 3-pin header row, and from P9 to the upper 3-pin header row. And then each of those rows will also have a 10K resistor where the other end connects at 3.3 volts. So that is your whisker circuit. Can you see that on the screen okay? Let me see if I can zoom it in. Okay, that should have improved it a little bit. And nope. I will build my whiskers circuit and then switch over to a nice close up on the camera. Does that help at all?
I just want to point out that the breadboard rows are not specific to any IO pins. It looks a bit like they're aligned, as if the 3-pin headers are lined up so that they line up with sockets or P7 and P9, but there is no electrical connection until you make the connection with the resistor. I wanted to point that out.
That's a really good point, Stephanie. What we did actually was we chose the most convenient IO pin to get to, given that we have to put the 3-pin headers so that they're next to the whiskers so that the whiskers make a connection. That set our arbitrary choice of these 2 rows for the 3-pin headers. And then from there, we said, well, gee, that row is kind of close to P9. So we'll just jumper the resistor over to P9 and then this one to P7 in the example. And make sure that you're going into those black sockets to the left of the breadboard labeled P7 and P9, not into the breadboard. I've seen students do that. So into the breadboard on the other end of those red, brown 220 ohm resistors. But on the left end here, definitely use those black sockets by the numbers.
Is it okay if I ask Andy, when you put the resistors in, and maybe just because it's like late in the afternoon for me, do the colors, the order of the colors matter or it doesn't matter? I'm sorry for asking such an uneducated question. I'm sorry.
Oh, come on. Don't worry about it at all. These are the questions that we need, because if you're asking it, a student's going to ask it, and we want to even potentially add it to the text. So yeah, your questions are golden. A resistor simply resists the flow of current, unlike a light emitting diode, unlike those little red lights that that we had to skip today. Those are directional. You plug it in one way, current will pass through it and it gives off light. You plug it in backwards, it prevents current from flowing. For this, it just resists the flow of current, and it does not matter which direction the current is trying to flow through the resistor. It's just going to slow it down.
Thank you. I just
Certainly.
got something from physics, but it's been a hot minute. Thank you.
Yeah, thanks for asking. Okay, so let's try out our test script.
I apologize. The neighbor has chosen today to do weed eating. But the whiskers touching each other, although they're supposed to bypass each other, what happens if they touch each other? As long as they're touching one post at a time, are we okay?
Yeah, they're allowed to touch each other because they both actually have the same voltage. And the main thing is we don't want one whisker to accidentally hang up on the other whisker. That would be bad. But if they touch each other, no problem at all. Okay, so let's see if we paste it from here instead of from the. Okay, so this is the whisker test code. Yeah, it's indented. Good. Make sure to plug your USB cable back in. Set your 3-position switch to 1. Connect your microbit if it's not already connected and hit flash. And then the test we want to run is going to be, you'll be watching the pixels in the middle row on your microbit. And as you press, with no whiskers pressed, there will be, let's see if I can get this with a better view here. Okay, so watch what happens when I press the right whisker into its post. See how it's the left post that gets touched. And see how when the right whisker touches that left post, how the light comes on. Okay, so right whisker touches left post, right light comes on. Left whisker touches right post, left light comes on. So when you push, this is the whisker on the right side here. It touches the left post, the right light comes on. Left whisker touches right post, left light comes on. How are we doing on that test? Good job, you guys. Excellente. Now, when you've got that test, and I'll zoom out and do it one more time just so you can see that I really am pressing the left and right. Okay, so here's the right whisker. Touches the left post. The right light comes on. Left whisker touches right post. left light comes on. Once your microbit has passed that test,
What happens if you get two solid lights without the whiskers touching?
that means there's a circuit error. Let's see, two solid lights without the whiskers touching. Two solid lights without the whiskers touching. Trying to think of what would do that. Just a second here. It's possible. Let's see if okay, so if I don't have the resistors connected to the correct sockets, that will happen. So I believe it's the P9 socket and the P7 socket.
Or if they're in a row different from the 3-pin headers on accident.
Yeah, so check your 220 ohm resistors, the red, brown that's going between the 3-pin header row and the IO socket. The P7 socket needs to connect to the same row as the, and actually for that matter, if the 3.3 volt isn't pulling it up, or I'm sorry, if the 10K resistor, the brown, black, orange resistor that goes to 3.3 volts, if that one's missing a socket, if it's off by a socket, so I just plugged it in one socket above where it should have been. And since it's not on the same row, it's not connected, and it's not doing its job of establishing, of telling the circuit that the whisker is not pressed because it's not plugged in. Plug it back in where it needs to go, the light goes out. See, so I need to paste in the script, or I'll paste you the link and you can copy in the script on your own. Okay, so here is the link. Lost my chat.
Yes, anyone who needs to go early or go not early, it's 2:30. The video will be sent out with the homework in an email.
Okay, so the link I just pasted in takes you to the example code. And although we normally prefer to have everybody typing it in with 1.5-hour sessions, it doesn't go so well that way. So, so this one was test whiskers. Okay. Paste in the new code, flash. And this one is so again, we want to flash the application code in. And then what you can do is simply take your robot, unplug the USB, and this is assuming that you've passed, that your circuit has passed all the tests. So this is a time when you want to set your robot on the ground and then test it out to see if the whiskers do indeed detect your hand. And the way we have it set up is so that some tuning is required, because I think you'd want it to really back up further in order to navigate around an obstacle. You can also speed it up, and these are things that students can do in there by modifying the script. Was that visible enough? Okay. Now, when it comes to script modifications, these sleep statements are the ones to increase. So you can say maybe back, or you can increase either the speed or the time. And so you could make it back up for maybe 600 milliseconds instead of 250. And really likewise with the turns. And then running that modified script. You'll have to click connect after you've unplugged and replugged your USB. Hit flash. And now it's going to back up further and turn further. So I like replacing those 250s with 600s. Okay, so have we got some roaming with whiskers cyberbots happening yet? Got one thumbs up. Good job, Chad and Tim and Stan.
Alberto.
All right. Sorry, missed you, Alberto. Edwin, good job.
Edward, too. Stephanie, yeah, great. Richard? Nada. Wonderful.
All right. Well, great work, everyone. And just a real quick thing on the homework. And then we'll go to troubleshooting and just getting everything, all of you with working whiskers who are able to stay with us. For homework, we're going to do infrared, which is basically being able to do it without whiskers. So one more time. So it's a lot like the whiskers, with the exception that the robot doesn't actually have to come in contact with the obstacle. So if you take an infrared TV remote from an older TV and shine it into your cell phone, you might see kind of a, you might be able to see the infrared shining into the lens of the of your cell phone or document camera. And I don't have one with me. All right, so these are the parts, and make sure that your clear LEDs, which are the infrared LEDs, are basically the same shape as your red LEDs in your kit. So you'll be gathering these parts. You'll be making sure that it has the same shape as the red LED. It doesn't have a flat top. It has a nice round dome top. And then you'll be putting it into an infrared shield. It's got 2 holes in the bottom. And then building this circuit. And then trying this code And the instructions have you look at little yellow lights below your printed circuit board to make sure it's working. And then we'll do any troubleshooting together as a group on making sure it's working. Although I do want you to do your best to try to figure out where your circuit error is by following the instructions that I'm going to send, the instruction list. And so that is essentially, it's going to be build the IR circuits is one of the pages, and then test the IR object detectors. And follow the instructions in those pages. And in the end, you will want to have this little P20 yellow light come on when you put your hand in front of the right, or I'm sorry, the P21 light should come on when you put your hand in front of the right detector and then go off when you take it away. And the P20 light should come on when you put your hand in front of the left detector. So here's the P20 light, left detector, P21 light, right detector. And that will be the test both sides together section of the test IR object detectors page. So this is the one for building it. So here are the parts. Thing about the shape of the infrared LED, how to put it into the shield, then the circuit and the wiring diagram. So that's one page. And then the next page is testing. And you don't need to do it one at a time. We'll just have you skip, in the interest of time, we'll have you skip down to this test both sides together section, which makes those lights go on and off depending on whether or not the infrared receiver, the infrared detector can see an obstacle in front of it. And so, so this tube is like a flashlight, and you'll be putting your hand in front of it, and it'll reflect back to this, this part. And if both of these are wired correctly, you will see when you put your hand in front of the right, P21 will come on, this light right here. When you put your hand in front of the left, P20 will come on, and then it'll be ready for the navigation scripts that come later in the chapter. One additional bit of homework is if you are not part of learn.parallax.com yet as an educator, if you don't have an educator account at learn.parallax.com, we created one for you and sent you an email. Follow the steps. It's not going to get in the way of any of the hands-on stuff if you don't have it done by Friday, but I am going to show you how to navigate to get to the teacher resources on Friday. And so you'll be able to go and do the same thing if you have the Learn account set up. If you already have a Learn account, you will not have received an account activation email. Instead, you can just go to this web address right here, and this will all be in an email. You can go to this web address and just log in or request a new login if you forgot your old one. There's a button for it. And
I have not actually sent that email. I am sending it now. I have the account staged. I will be sending that email in about 5 minutes.
Oh, pardon me. So the email is coming soon.
Yes.
All right. So that concludes today's session, at least the recorded part. So let's go ahead and stop recording, and we'll we'll move on to getting everybody going with their who doesn't have their whiskers robot going yet.
And yes, you will be getting a homework email.
Yes.